I'm going to begin here by giving another example of the time value of money calculations and some important ideas we can learn about personal finance and savings from these time value of money concepts. Time value of money, these ideas will run through many of the chapters in the course. And the sooner you get adept at looking up things in the tables or using the spreadsheet, uh, the more able you'll be able to learn about the ideas and not get bogged down in the what might seem like confusing mathematics. In this little lesson today, I want to talk about the parable of two people who are saving for retirement. One of the people's name is Elizabeth Early, and the other one is named Larry Late. And these two people are, in many ways, very similar, except in how they're going to choose to save for retirement. Elizabeth Early is going to start working at age 25. The same that's true for Larry also. But Elizabeth is going to start saving for retirement immediately when she starts working at age 25. I'm going to assume for this example that she saves $5,000 each year, but she's only going to save for 10 years. So she's going to save between age 25 to 34. So for 10 straight years, she's going to set aside $5,000 each year. So in some ways you might say, well, she's just going to be saving $50,000 for retirement, and that is going to be woefully inadequate for her to retire. But we need to take into account compound interest and what that money will be worth in the future. What I'm going to assume is after 10 years, so when she turns 35, or at the end of her 34th year, she's going to stop saving. But the money that she's accumulated through those 10 years of saving, she's going to allow to continue to accumulate earnings for the next 30 years. And so when she's at 65, she's going to go back and look at how much that pot of money is worth. I'm going to assume both for Elizabeth and Larry that they can receive an 8% interest rate on their investments. That might be a little low early in life and a little late as you approach retirement, as your portfolio will change likely as you get towards retirement. But for simplicity, let's assume it's 8% throughout. The question for us to think about is how much will Elizabeth have when she retires? That is, what will she be looking at in age 65? Elizabeth's problem is actually a two-part problem. We need to break this problem into two steps. In the first part of the problem, we need to think about how much money is going to accumulate during that 10 years while she's saving money. And then once we've gotten to the end of her saving period and all she's doing then is allowing the money to gain interest, we're going to need to look at the accumulation during the just kind of this interest earning period. So the first part, how much is she going to accumulate during the 10 years of savings, is you're going to need to go to the Excel spreadsheet I spoke of in the previous lecture. It's titled Chapter 1, Excel, or Time Value of Money. And in there's something called Future Value of a Series of Deposits. I'm going to switch to that spreadsheet right now. You can see this little section of the spreadsheet is called Future Value of a Series of Deposits. I have Elizabeth saving for 10 years. The interest rate is 8%. And she's going to be saving $5,000 a year. Okay, those are the three key facts you know. $5,000, the interest rate of 8% for 10 years, and over here, this spreadsheet tells me that at the end of 10 years, she will then have $72,432, okay? So at the end of 10 years, she's going to have $72,432. Okay, and now she's turned 35 and she's going to stop saving. Okay, now what we need to do is ask how much that $72,432 is going to grow over the next 30 years. So we're going to go back to that spreadsheet and look at the part of the spreadsheet that says future value of a single amount. So basically we're going to think about that this $72,000 right here, she's going to put in a lump sum and then grow for 30 years. So let's go back to the Excel spreadsheet. Right up here, future value of a single amount. I have here that she's going to be saving for 30 years. So from the time she turns 35 to 65, she's going to have 8% interest rate. And this $72,432, this amount right here, I know that value right here because that's what the previous calculation, the part 1 calculation, told me. Okay, the spreadsheet calculates the multiple factor, which is 10.063. And so this $72,432 will grow. So when she's 65, it'll in fact be worth $728,866. Okay, so this 10 years of savings, so effectively $50,000, after the 10 years of savings and then 30 more years of allowing it to accumulate and grow, she'll in fact have $728,866. Okay, so that's what her decision to start saving when she was quite young, that is age 25. She'll have almost $750,000 when she's 65. Let's now contrast with Larry Late. So Larry Late's very similar. Larry Late maybe starts working in a very comparable job to Elizabeth, but between age 25 and 35, Larry is spending his money on other things, perhaps buying a car, other things like a couch, TV set, whatever. He doesn't save any money for retirement is the idea. However, when he gets to age 35, he says, oh, I need to start saving for retirement. So my idea with Larry Late is he doesn't save the first 10 years of his working career, but he starts at what you might say is actually a relatively early age 35. He's going to save $5,000 each year. So in that sense, he's like Elizabeth. He's saving $5,000 each year. The difference is he's going to start at age 35. The other difference is Larry's going to save for 30 years, where Elizabeth only saved for 10 years between 25 and 35. Larry is going to save for 30 years. So Elizabeth saved effectively $50,000. That was her capital, 5,000 times 10 years. Larry's going to be saving $150,000. The 5,000 times 30 years. Okay, he's going to save from age 35 to basically end of his 64th year. He's going to wake up at age 65 and retire. And the question we have, just like with Elizabeth Early, how much will he have when he retires at age 65? And we're going to assume, as we did with her, that the interest rate is 8%. Okay? Larry's problem is a little bit easier. It's just a one-part problem. It's the money accumulated during the savings period. Okay, so we're going to need to go to the Excel spreadsheet and think about what he's doing. He's saving $5,000 each year for 30 years. That's a series of deposits. So we're going to go to the future value of a series of deposits section of the spreadsheet. Okay, future value of a series of deposits. Okay, he's saving $5,000 a year. His interest rate is 8%, but he's not going to save for 10 years. That was the entry I had for Elizabeth. I need to change this to 30. He's going to be saving for 30 straight years. And right here, the value that he's going to have, therefore, at the end of 30 years, it says right here is $566,416. Okay, so starting at age 35, saving $5,000 a year each year until 65, you will end up with $566,416 when you retire. Okay, and that's the value I have right here on this slide. At the end of 30 years, he's going to have $566,416. All right, so let's do a quick comparison of Elizabeth Early versus Larry Late. And for me, this is really a very, very surprising implication of the time value of money. Elizabeth Early saved only for 10 years, from 25 to 35. $5,000 a year for 10 years. She actually only invested $50,000 of capital. And for whatever reason, we don't really go into it, but we suppose she stopped saving for retirement. Nonetheless, the calculations show that she would end up in retirement with almost $730,000. Larry Late saved from age 35 to 65, 30 years at $5,000 a year. So he does 3 times the amount of the capital investment. Rather than $50,000, he has $150,000 of money that he chose to put into his retirement account. Yet, because he started later, he's only going to end up with $566,416. This is a difference of over $162,000 between Elizabeth and Larry. Elizabeth is going to end up with $162,000 more dollars than Larry. So the moral of the story is the early bird gets the worm. By saving early, Elizabeth ends up with far more money when she comes to retire than Larry does. And so my plea to you, one of the big things I want you to take away from the course is please start saving early. I know when you're 21, you think retirement is so far away. I really care about getting a car or buying my house, etc. But I am going to try and reinforce over and over in this course the importance of long-term investing to make yourself comfortable in retirement. Maybe you're going to be able to take early retirement. But the bottom line is at some point in your life, you will say, oh my God, I only have 10 years, 15 years, whatever number of years when the realization hits you that you will retire. If you wait until it's really clear in your mind that there's a retirement date coming, you will have waited too long. Elizabeth, in this example, by starting to save in her 20s, ends up, even though she only saved for 10 years, which is probably not accurate, she would probably be saving her entire life. But in this example, by saving only 10 years, she ends up with far more money than a person who starts saving late. But I can actually hear you through my computer. I can hear you saying, how am I supposed to be saving when I first start working, Professor Prusha? I have college loans, I have clothes I need to buy, I have things that I want to get, and I've been waiting years and years to finally get my job so I can start buying things. I agree entirely with you, and I completely get what you're saying. It's really hard to do. On the other hand, that does not mean it isn't worth doing. The example I just gave you is not rigged to give this result. That is exactly what the numbers tell you. Okay, you can pick different interest rates. You can do more complicated examples, and I'm going to produce more examples of this for you. But the idea of long-run consequences of saving early really are life-changing as you move on. Here's my suggestion. This is what happened to me in my first job. I'd like to tell you I had it all thought out, but I'd be lying to you. Okay, one of the requirements of my first job was it was not a choice, I had to save a certain amount of money each paycheck with a certain percent of my paycheck. It was requirements of the savings, and it turned out to be, I look back and feel very lucky this was a requirement. So, I went from having a very small amount of money, probably like many of you right now, to when I first got my first job, it was like, wow, I have a lot more money now, like 3 times or 4 times the money I had when I was working part-time as a student. I had just a lot more money. And by having money automatically deducted from my paycheck and put into it turned out to be a retirement savings account, I didn't really feel that I was having the money taken out because I still had a much larger paycheck than I'd ever had before. So yes, was it 5% less than it might have been? Yeah, it was. And maybe that 5% I would have spent in some really excellent way. But now as I've gotten older, I'm really glad that that money was I was required to save it, and I ended up now I'm well along towards trying to save for retirement, and that is actually a hope I have for all of you. So I want you to go back and look at this example. Think about what this might mean, and in a few years, whether some of you it's in June if you're seniors, or some of you might be 2 or 3 years from now, I want you to remember this example of the importance of starting to save for a long run goal. Retirement is a long run goal, uh, and what early savings can do for your goal. All right, have a good day.